Alright, good evening. I'm making this video for my student that I care the most for the private pilot certificates. He is doing fine. Today we are going to make a flight plan from Goodyear to Yuma. And the plan is to depart Goodyear Airport at 7 o'clock tomorrow morning. It is Arizona, so there's a time difference between 7 hours from Julu to local time. Fuel elevation at the Goodyear Airport is 969, but about 1000 is good. We are going to climb up to 6500 and come down to Airport of Yuma, that is about 400 feet mean sea level. Okay, here's just overlay Goodyear Airport. We're going to make a flight to Gila Bend and follow this Victoria way. Here's one way to recognize this point is Mohawk, one of the GPS point as shown over there. Well, another name will be Dust Wing. That'll be a visible restaurant points. You can check it on the Google Maps. And then following the bar BOR for the 075 radial inbound. Over there from the Goodyear to Gila Bend BOR, it could be similar from Goodyear Airport. After taking off, flying 210 heading edge or 198. And you checked the Gila Bend BOR, which is a 116.6 at about 015 radial inbound and fly outbound right approximately on the 247 radial outbound, and it'll get you to Dusty Wings. But while you're flying it, you'll be able to look at the highway, which will be on your left side or below the left wing. Keep tracking the BOR outbound on the Peter 66, which was a 247. And later on, by the time you get to the Dust Wing, what you can do, you can check 075 radial from the BARD VOR 116.8 radial inbound. And as long as you get a fly following, they'll switch you frequency from, let's say, at the very beginning from the Goodyear Airport, you'll be on their either Luke approach or the Phoenix approach. And as you get farther away, you'll be switched to the Albuquerque. And after Albuquerque, you'll be hand over to the Yuma approach. And from Yuma approach, they'll tell you which direction you need to go, and they'll tell you to contact the Yuma Tower. So that'll be home. Okay, so here's the time to talk about the time and fuel distance required for the climb. Okay, I gave you the really hard version, but let's stick to the easier one so you have an easier time. But remember, in the instrument rating, you'll be have a harder time. Here's a PIM from the Cessna 172S. Oh, that's a school name, but Cessna 172S. Performance on the section 5. Go to the figure 5.7 time fuel distance to climb. Okay, Goodyear Airport is from 1000. Okay, and then that's the next one. Alright, we are assuming 1000 feet going up to 6500. Okay, 2/3 is because if you say we take like take like 10 minutes to climb the whole 5500 feet, it'll be approximately 5 minutes here and 5 minutes there. It's because of the air is more dense on the bottom and less thinner on the top, and airplane perform better at the low altitude and less on the higher altitude. So about half and half. If you get the weather information at this altitude, that's going to give you approximately just average weather value for the whole altitude. Okay, so coming from 1000 feet going up to 6500 feet. If you are to go from sea level to 1000 feet, it'll take 1 minute. From sea level to 6500 feet, it'll take 11 minutes. So subtract 11 minus 1, that's going to take about 10 minutes. Assuming what? That if the temperature is standard temperature. Assuming that you have lean the mixture for the maximum RPM. But temperature will be different, so we are going to change that. Fuel use per gallon, let's see. Sea level to take 0.4. Sea level to 6005, it'll take about 2.4. So 2.4 minus 0.4, that give you 2.0 gallon. That is from 1000 feet going up to 6500. Assuming what? Again, flaps up, full throttle, standard temperature. But we are going to change it for the different temperature later on, because we are going to take the 2/3 value of the wind temp. Okay, so that was the time, and that was the fuel, and now it's time to talk about the distance, and that's about the top of the climb, right? You'll see Distance, how is it going to happen? So from sea level going up to 1,000 feet, it takes about 2 miles. From sea level going up to 6,500 takes about 14.5. So subtract those two, what we are going to get? 14.5 minus 2. This is going to give us 12.5 nautical mile. And what we gotta do? We are going to factor this thing. Increase time, fuel, and distance by 10% for each 10 degree above the standard temperature. Okay, then we need to get the standard temperature at the 6,500 feet. Okay, at the sea level, it'll be 15 degrees Celsius, 1,000 feet, 13 degrees Celsius, 5,000 feet, 15 minus 10, so that's going to be 5 degrees Celsius, 6,000 feet, 3 degrees Celsius, 6.5 thousand feet, it'll be about 2 degrees Celsius. Or the easier way to do this is like 15 degree minus 6.5. Okay, 6.5 times 2, that is about 13, so it's supposed to be 2 degrees Celsius. Okay, that'll be the standard temperature at 6,500 feet. And let's see, go look at the thing. Okay, assuming we are departing at 7 a.m. tomorrow morning, it'll be 14 July time on the 5th of February. Go to the aviationweather.com. Alright, there's a wind time. And what are we going to get? Let's see. There is a couple of the places we can get the wind temp value for Goodyear and Yuma area. But let's see. Wind temp forecast. Go to the forecast and wind temp. America is divided into several places. One is Circle Lake and one is San Francisco. And near the Yuma, we'll be looking at the San Francisco Pacific Coast. But for the departure, at least, we are going to use Circle Lake, where they're going to talk about the Phoenix. From the Phoenix, what time period do I need to use? It'll be the time period that including 1400 July time. That's the tomorrow's date. So don't take the very first one. 14 point July is between 9 to 18. Okay, 14 point July. Based on the time, it was made on 1700, which is 5 p.m. on the 4th, which is the Tuesday. It is valid for blah 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 for use time from 2 a.m. going up to 11 a.m. And we are going to depart at 7 a.m. so that makes sense. Let's look at that Phoenix. You see the temperature over there? 3,000, 6,000. Okay, because every 1,000 feet temperature drop by 2 degrees, right? So every 500 feet it'll drop by 1 degree. So in the forecast, what he's saying is that around the Phoenix area at 6,500, the temperature at 6,500 will be about -5. -5 degree. Okay, -5 degree is 7 degrees lower than 2 degrees, right? So is 70 degree lower than standard temperature. Okay, go back here. Increase the time, fuel, and distance by 10 degrees for each 10 degrees above the standard temperature. It doesn't say anything about colder. If it is a winter time, the temperature is 6,500 feet, and near the Phoenix area is going to be actually greater than what is standard temperature. It's going to be greater than 2 degrees in the winter time, but right now is colder. Why? Yeah, because the cold front has passed by yesterday and the whole area is cold. But when you look at the performance chart on the 5 p.m., it says increase for any temperature above that. If it is lower, we are not going to do anything. So top of the climb, we are going to assume it'll be 12.5. In reality, it's going to be less than 12.5, but we'll just assume a lower, worse performance for the airplane and go with that. Alright, so that's the top of the climb. How far it is going to be? 12.5. So let's see. Assuming coming in that 12.5 from the sky vector. Okay, here's a sectional Phoenix. Here's a Phoenix sectional, and one ring is about 12. The compass rose around the BOR is about 10. So let's see. That's about 10 degrees. There is about your top of climb. around here. But remember, in the reality, on the departing from the Goodyear Airport, we are going to level around at 3,500 just to avoid hitting this Bravo airspace at 4,000. Anyway, top of climb will be about here. And what's going to be your climb airspeed? It'll be climb indicator airspeed of that and that. Okay, and it's time. Let's see, indicator airspeed we are going to maintain about 73 nautical mile. And what we need to get now is time to get okay, give me 1 second. I know things are around the school, but here is E6B for the conversion on the all that. What are you going to do? Now it's time to talk about the 2/3 belly of that. So here is 6,500. You did well, Zin. Okay, 5,500 multiply by 2/3 ish, which I don't have my brain power to do that, so I'm going to ask calculate to do so. Divide by 3 times 2, give about 3,600 something, so 3,650, and that's from the fuel elevation is 1,000, so they give that, and that's going to be about 400-650 ish. Okay, 400-650. What's the temperature is going to be there? Go back to the wind temp again. 4,650 ish is about between 3,000 and 600, right? So I'm going to get the temperature estimate based on this. So at 5,000 feet, it'll be 2 degrees greater than 6,000, right? So it'll be -2. At 4,500 feet ish, let's see. Based on the wind temp at 6K, forecast tell you the temperature is going to be at -0.4. At 5,000 feet with standard rate, it'll be -2. And about 4,500 feet is going to be -1. I am adding 2 degrees. For 500 feet, I'm adding 1 degree, so -1. Okay, you see that temperature? All right, now it's time to do this conversion. There is 2 windows on the left and the right. The one on the left side is for the altitude. The one on the right side is for the airspeed. Okay, what you gonna do is say opposite the CAS inner scale, read the TSA outside, right? We need a CAS, calibrated airspeed, inside. But what we found on the indicator airspeed is not calibrated airspeed, right? Then it's time to change the calibrated airspeed or something. Calibrated airspeed for indicated airspeed. Okay, and the sad thing is that airspeed calibration, here's an alternate steady port, though we are not using it. We will be using a normal steady port that is under figure 5.1. Condition: power required for the level flight or maximum power descent. And technically we are not supposed to use this chart because we are climbing, not the level or power. But what else can you do? We'll just stick with it. So indicator speed about 73 is going to be around 73. Not so much difference, right? So from the chart showing a maximum climb, time, fuel, distance, climb. Okay, here's a 73 indicator speed, but that's from the 5.8, figure 5.7. And from the airport calculations, it'll be from figure 5.1 from the 5-9. We'll assume the indicator speed and calibrator speed is same. Okay, now back to the E6B. We are using the airspeed correction, right? For the whole climb, we'll be taking the value from there. What is the temperature time? And around here, it's about 0.1. Sorry, -1 degree Celsius. So over here, you come here, not setting the 0 equal to, okay, thousands of pressure altitude. Yes, you did correctly, but where you want the altitude over here, not the altitude at the field elevation. So around that 2/3 ish, the field elevation will just assume, because usually the altitude setting doesn't vary more than like a 1 inch of mercury. It's usually within 0.01. That's like a 1/100th of the inch of mercury. So I'm gonna ignore that. So 4,500, 0.1. Okay, Over here is a 0 degree. Over here is a 0 degree. Here's a 10, 20, 30, 40, 50. But -1 is almost like a 0. So we are using a 0 for what altitude? 4.5. So here's a 1,000, 2,000, 3,000, 4,000, 5,000. Between that, sorry, 1,000, 1,000, 2,000, 3,000, 4,000, 5,000. Okay, so I'm setting 0 degree and supposedly minus 1 degree at 4,500. So about that, and then you fix it so the roll E6B doesn't roll. What do I need to go? It says set the CAS inside, right? CAS is inner one. Oh, yep, setting it one more time. Okay, so there it goes. -1 to 4,500. Inner CAS is 1, 2, 3, and outside TS will give us about 75, 6, 7. Yeah, 73, 77, 78, 73. Sorry, that's my belt. So 77 nope. 77 TAS for the climb from field elevation to that. So at the end, you got the right answer. You have a good day. Let me know of any more questions. Remember, we are getting the temperature value from the forecast, and yep, under the forecast wind temp, make sure you're getting the right time period for that. For the departure, we are using a wind temp based on the Phoenix, which is on the Salt Lake City. For your arrival, you kind of need to know that we are going to the Yuma, right? Yuma doesn't have the nearby place, but we'll use a San Francisco and go to the place. From descent from 6,500 feet to going down, and unlike the climb, we'll be using a steady descent like a 400 FPM or 500 FPM, so we are going to get the wind temperature value there, which is about half of the height. Okay, half of the height, and always think about the time of your arrival. Okay, somewhere there between 6,500 to 4,000 feet, so there'll be 3,000 between, about 3,500. So you'll be using the temperature value that is expected at 3,000. No, we don't see any value here. That's because it's within 1,500 or 2,500-ish. If there's nothing within 1,500 from the field elevation, within 2,500. Okay, so there's 3,000 difference. 6 degree higher than that, that's going to be 2 degree. And 2 degree, just giving you an example. 6,000 feet, 0 minus 0.04, and 3,000 feet, 3 times 2 plus 6, those it'll be plus 2 degrees Celsius. But on the standard sea level, it'll be 15 degree. 3,000 times 2, it'll be 6 minus 9 degree. So it'll be still 7 degree less than that, right? We'll stop there. Have a good day from Jamie Kim.